Hello everyone, this is Venkata Ramana, Professor of Automobile Engineering, VNR Vijay IT. Last session, we have discussed some of the components of engine manufacturing methods, and we continue the last topic, that is last session topics, and today we are going to discuss some more components of automobile engine manufacturing methods. So that's what you can see. Title of the today's class is Manufacturing Methods of Valve Seat and Connecting Rod. So you can see here, so this is valves and this is connecting rod and this is valve seat. So today we are going to discuss how do we manufacture these components using conventional manufacturing methods. Valve seats, connecting rods are the essential components in a internal combustion engines, that is IC engines, and their manufacturing involves very precise engineering techniques to ensure durability, efficiency, and reliability. So let us start with valve manufacturing methods. So these valves we use in engine so to control the flow of air, that is inlet and fuel, into the combustion chamber and exit of exhaust gases through exhaust valve to withstand high temperatures and pressures, and they are manufactured using different methods such as forging, casting, and machining. So each method offers unique benefits in terms of strength, precision, and cost. So this is the structure of engine valve. It consisting of basically two parts. One is head, another one is stem, and there are minor elements of this engine valve is a tip, keeper groove, fillet, seat face, margin, combustion face. And the materials mostly we use to manufacture the engine valves are Martensic stainless steel, ferritic stainless steel, and austenitic stainless steel. So this is a sequence of steps we follow for manufacturing of engine valve. So first we have to take the raw material and cut it into desired length or desired dimensions, and then we use friction welding or extrusion to get cylindrical rod, and then we go for deburring for finishing. And then the next step is upsetting to get the face of the valve, and then we go for surface treatment to improve the properties. Similarly, we go for heat treatment again to improve the properties. Then we go for forging process to get the valve head shape, and then we go for machining to improve the dimensions of the component, and then we go for assembly, and then we go for inspection of the engine valve, whether we have received correct dimensions or not. So this is the flow process of our steps in manufacturing of engine valve. So as we discussed earlier, there are different methods, and here this is one of the method. Here this is a method we call as friction welding. Here there are two components of the engine valve. So one we divided into stem, another one is head. So these two are combined or joined together using friction welding. So this is one of the method of manufacturing the engine valve. So here you can see the joint that is that is welded using friction welding. So here another method is upsetting process that comes under the forging. So in the forging or upsetting process, the valve head is forged using forging process, that is upsetting process. In upsetting process, the diameter is increased and the length is decreased, whereas this one is the stem, and the stem is we are not going to change any dimensions, only the head portion we are going to change the dimensions using upsetting portion. And after upsetting, so we use CNC turning to get the groove at appropriate position. Once the component is manufactured with the primary manufacturing methods like forging or friction stir welding, then we go for heat treatment process, where the heat treatment consisting of quenching process, washing, and tempering process. In quenching process is used to reduce the crystallinity and increase the toughness, whereas the tempering is used to reduce the brittleness of the material. So that is the next step after manufacturing the valve. that is heat treatment. Once the heat treatment is over, then we go for surface heat treatment, which is also called as a short blasting. In short blasting, surface treatment technique employs with a high velocity steel abrasives are hitting onto the surface of the wall so that it cleans the surface as well as it undergoes the treatment. So that also called as secondary finishing process, which produces the good results in terms of surface strength. After all these two process, we go for final machining process to get exact and the required dimensions using machining process. Mostly we use turning process. So that's what you can see here. Different stages of manufacturing the valve using forging process. So initially we take cylindrical rod, and then using upsetting, that is forging process, we manufacture the head portion of the valve using upsetting process. Then we go for machining and the finishing so that we will get exact dimensions. So that is the precision machining is performed to achieve the exact dimensions and the smoothness of the surface, which includes grinding, lapping, polishing to enhance the wear resistance. After that, to improve the further properties, that is improve the lifespan of the valve, we go for chrome and nitrate coating to reduce the friction as well as increase the lifespan, that is life of the valve. So not only surface treatments, we also go for induction hardening to improve the hardness. And there are two methods of surface treatments mostly we use. That is, one is hard chrome method, so where the chromium is deposited on the surfaces, and that is the thickness is from 2 to 250 microns. That is first method to improve the surface hardness. As well as we can also go for nitrate coating, so where we use nitrate coating with physical vapor deposition. So these two methods we use for improving the surface characteristics or surface properties of engine valve using surface heat treatment. And this is a CNC grinding machines to improve the dimensions or dimensional accuracy of the valve. So that's what you can see here. These are the valves after manufacturing the using CNC surface grinding process. And next component is valve seat. So this is a valve seat, and here also you can see valve seat. The valve seat ensures the tight seal between the valve and the cylinder head so that unnecessary leakage of gases may be inlet through inlet valve or exhaust valve. So to avoid that, a seat is required, and that seat you can see, this is a seat that is inserted in the engine valve entry place. The common methods for manufacturing the seat valve are powder metallurgy, that we have discussed in the last class or last session, and the casting and CNC machining. So the powder metallurgy process, where we take the powder and the powder we blend it into by adding the binder. Then we go for sintering process to get the required shape, and then we go for compacting so that we get the required shape and size. Okay, so these are the sequence in powder metallurgy. That is, first step is powder mixing, that is we call as a blending, and then we go for compacting process, and then we go for sintering process so that we get required shape, size and dimensional accuracy also. So which produces a precise material composition and enhance the durability of the valve seat. And the next method, mostly used method, is investment casting. So here the productivity is also improves, and in investment casting we get good surface finish. To get the good surface finish, we use grinding process, boring process and the turning process. The turning for external surface finishing, and the boring process for internal surface machining, and the grinding process is overall surface improvement process. After that, we go for surface treatment. Mostly we use nitrate carburizing process, which increases the wear resistance. And the next method after mostly used powder metallurgy process is investment casting process. So this is a general casting process. In investment casting process, first we make wax patterns using wax material, and these wax patterns are attached to a central sprue with a gated system, and then the pattern clusters are dipped into the ceramic slurry several times until we gain required shell thickness. After that, the pattern cluster is fired so that the molten metal is poured into the ceramic mold after the wax is evaporated. Finally, the mold is broken from the casting so that exact valve seat can be obtained from the casting process. And after obtaining the valve seat from the investment casting process, we go for surface finishing methods. So valve seats are the surfaces against each engine valve close ensures the proper sealing in the combustion chamber. The primary function is to facilitate the efficient heat dissipation and maintain the compression within the engine. So that's the purpose we use valve seat. The materials used for valve seats are cast iron, aluminum steel, copper and beryllium, and powder metal inserts. So these are the different manufacturing methods for valve seat. And then last component for today's session is connecting rod. So this is a connecting rod. It is a very important component, and that links the connecting rod links the piston to the crankshaft. To crankshaft must be withstand the external, that is extreme forces which are obtained or developed from the forces which are obtained on the piston. So connecting rod mostly we manufactured with a forging process, and sometimes we also use casting process, and very rarely we use powder metallurgy process. The materials used for manufacturing of connecting rod are steel, aluminum, titanium, cast iron. Sometimes we also use carbon steel, iron based sintered material, microalloy steels, spheroidal, graphite, cast iron. These are the materials we use for manufacturing of connecting rod. So the one of the method to manufacture the connecting rod is casting process. So in the casting process, you can see here, this is a die. So that is mostly we use die casting process. In a die cavity shape of casting connecting rod is prepared, and then we pour the molten metal into the die, and after solidification we take it out, and finally we are going to get the connecting rod using die casting process. And the next process is drop forging process, and this is a generally used manufacturing process of connecting rod, that is drop forging. So in the drop forging there are several processes involved with the die. So this is a die, and these are the steps in getting the connecting rod from the raw material to final shape. In the first step, we take raw material in the form of a stock, and then we go for first step of forging we call as a pullering, and the second step we call as edging, that is pullering to edging. So we get a middle or a rough shape of connecting rod, and then we bend it to required dimensions, and then we go for blocking to get free final shape of the connecting rod, and then we go for finishing step, so where we get the final shape of the connecting rod after removing the excess material in the form of a flash. So this is drop forging method, mostly used method of manufacturing the connecting rod. And after manufacturing connecting rod with casting and forging process, we undergo machining process to get final dimensions. So that is precision machining is a critical for the tight tolerances and the proper fitment between the piston and the crankshaft. So that's why we go for machining process, and the heat treatment is necessary to improve the strength. Mostly we use heat treatment processes are carburizing and a nitride process. And surface treatment, after heat treatment we go for surface treatment like shot peening to improve the fatigue resistance and lifespan of the connecting rod. So this is for improving the surface characteristics and dimensional characteristics for the connecting rod. Okay, so That's all for today's session, and we'll stop it here. In the next class, we'll see how to manufacture the crankshaft and camshaft. So that's all for today. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.